and especially along with its mass and charge and spin and color, put all of those together and you will know exactly which particle we're talking about, okay? Stephen, good night until next time. Can you hear me and see me okay? What are you guys talking about? Can you see me and hear me? Can you hear me, see me okay? Oh, thank you. John Jones says I love consistency. Thank you. Thank you so much, everybody. Thank you for confirming. Thank you, thank you, thank you. Yay, thank you so much. Okay. Okay, so again, spin is one of those intrinsic properties that basically define the state of the particle. And also, along with other information about the particle, such as its mass or its charge, we can even know which particle exactly. Okay, and thank you so much. And thank you so much for being here. And thank you for the likes. And can we get 40 likes? Although early work focused on the electron, physicists have subsequently shown that these ideas about spin apply equally well to all of the matter particles that fill out the three families. So what are the three families of particles? Once again, these are leptons, quarks, and bosons. So we haven't talked too much about particles from this book, at least recently, but those are the three families of particles. We just know it. We have seen that before and whatnot. Okay, can we get 40 likes? I think Seaman is liking and then unliking so that the numbers of the likes are changing. Thank you, Seaman, so much for all your engagement. And thank you for the super chats as well if somebody wants to do that. This is true down to the last detail. All of the matter particles and their antimatter partners as well have spin equal to that of the electron. So all of the matter particles, including the quarks, have spin equal to that of the electron. So same spin as the electron, okay? In the language of the trade, physicists say that matter particles all have spin 1/2. So this is what we call the spin of an electron or the other matter, like or quarks as well. And this is called spin 1/2, where the value 1/2 is roughly speaking a quantum mechanical measure of how quickly the particles rotate. Moreover, physicists have shown that the non-gravitational force carriers, these are photons, so non-gravitational force carriers would of course be the other forces other than gravity. So now what are those other forces? Once again, electromagnetism, strong nuclear force, and weak nuclear force. So those force carriers are, again, photons, weak gauge bosons, and gluons. Also possess an intrinsic spinning characteristic that turns out to be twice that of the matter particles, and they all have spin 1. So the spin or the intrinsic spin property of the matter particles is different than that of the force or the gauge particles, the force carrier particles. Matter particles have spin 1/2, what we call spin 1/2, which is a way to describe the spin of the matter particles, such as that of the electron, and force particles have a different spin, which is spin 1, okay? Feeling quirky, hello. Is this where I get to say how beautiful you look tonight? Thank you. What about gravity? Well, even before even before string theory, physicists were able to determine what spin the hypothesized graviton must have